Alright, so today we're going to begin the Chapter 8 portion of the review for the final. You will need your graphing calculator, especially for the first one. As far as your flip book goes, average rate of change is brought up again. That's in our blue one. Okay. So the first thing is the function. Here it is. It models the height in inches of a kingfisher bird as it dives into the water to catch a fish. So it wants us to put that in the graphing calculator. So just remember, go to y equals. I've already typed it in. And I've pressed zoom 6, and this is what I have. If you read it, you need to have a good window so that you can see all the important parts of your graph. So the y-intercept, can't see that. The x-intercepts, I can see that. And then the max or the min. This has a min, but I can't see that. So what I need to do is stretch this going up and down. I need to change my y values. So I'm going to go to the window and just change it to go up to, now I can see that the y-intercept is 15. Remember, this is standard form. In standard form, you can see the y-intercept. So I'm going to have the max actually go up to 20, and I'm going to have the min go down to, let's just do negative 20 and see what this looks like. Alright, so it's still not quite low enough, so I'm going to change it one more time. I'm going to change it to negative 40. And I'm just picking these numbers randomly, no rhyme or reason to them. Alright, so that works. So first we need to draw the picture, and we're going to mark all those key points. So here's the x-axis, here's the y-axis, it's my y-intercept, and I'll put these as my x-intercepts, and just my vertex down here, and then do the best job you can to make that u. Okay, so the first thing I'm going to do is find the min. At this point, we're going to second trace to that calc option, and for the lowest point, I'm going to choose 3. And remember, when it says left bound, I need to use my left and right cursors to move down so it's on the left side of this low point, which it is. So I'm going to hit enter. It doesn't have to be in the exact spot as mine, just to the left. And then it's going to say to the right, so I'm going to use my right cursor to go to the right somewhere. Hit enter, and then it's going to say guess. And it's about I'm going to use 4.2 and negative 37.1 is how I'm going to round those. So 4.2 and negative 37.1. Okay. Now I'm going to go for my x-intercepts. So when you go back to second trace, your x-intercepts are your zeros. And again, I'm going to use my left arrow to get to the one on the left. And it's got to be to the left, which is more like it's above it. So that works. Hit enter, and then once to the right, which is below it. And then hit enter for guess, and that one is, I'm going to use 0.7 and 0. I'm just going to round. It didn't say how to round, so we'll use to the nearest tens. And then I'll do the other one. So back to second trace, choose 0 again, use your right cursor to go to the right. And to the right, so to be on the left, I need to be a little bit below it. Hit enter, and then I'm going to go to the right, above it. And for this one, I'm going to use 7.7 and 0. Alright, so I had to answer the phone, so coming back to this. The last thing I need to find is the y-intercept. And again, since this is in standard form and we've gotten to this point, you can see the y-intercept. So I already know without a doubt that this is 0.15, and I don't need my calculator to tell me that. So, so now it says find the value of the x-intercepts. Great. Label them on your graph. We've already done that. Again, they are 0.70 and 7.7 and 0. I'm just going to wrap those in parentheses. And what do these points mean in the graph? Well, again, this is about this is modeling the height when a bird dives into the water. So basically, this is the x-axis is referencing time, I would assume in seconds. And the y-axis is referencing the height. And again, I'm going to assume probably in feet. Oh no, it says inches on there. So basically what this means is at 0.7 seconds, the bird is diving, ooh, sorry you can't even see that, 0.7 seconds the bird is diving into the water. I'm going to abbreviate water, H2O. And at 7 seconds, it's coming out of the water. Okay, so maybe pause that so you can write it. But again, this is, think of the x-axis as the top of the water, and here he's up in the air, and here he's down in the water. All right, what's the lowest height the bird ever reaches? That's the vertex, that's our minimum. And again, x is time, y is the height. So I only need this number. It's about negative 37 inches below the water level. Again, whoops. All right, now I'm going to fill in the following heights of the table. So I'm going to use the table from the calculator and just 3, 4, 5, 6, 7, 8 and put those numbers in. So I've got just copying straight from here. So I'm going to move the calculator and write those down. So I've got negative 33, negative 37, negative 35, then negative 27, negative 13, and 7. So basically at 5 seconds, it's this many feet below the water. At 8 seconds, it's, sorry, not feet, inches, it's 7 inches above water. It's back in the air. All right, we're going to find the average rate of change now using the information from our table. So again, average rate of change was in our blue book. We discussed it last week when we were doing that computer sample test. And it's just subtracting your y's and your x's. Okay? So let's just make a little note of that. Subtract your y's, subtract your x's, and we will have to use our calculator to get it down to 1. So with 5 seconds, our y value is negative 35. And with 6 seconds, it's negative 27. So I'm going to subtract my y's. It really doesn't matter how you do that. I'm going to take negative 27 and subtract negative 35. So since I went this way for the y's, I'm going to have to do the same for the x's and do 6 minus 5. So you can add the opposite, but it basically becomes negative 27 plus 35, and that's going to give me 8. And then subtract my x's, it's 1, and there's my rate of change. So it's moving 8 inches every 1 second. Okay? And now I'm going to do the average rate of change from 6 to 7. So 6, again, has negative 27. 7 has negative 13. And I'll subtract those. So the y's, I'll do negative 13 minus negative 27. And that means I have to do 7 minus 6. Denominator simple, there's 1 again. I'm going to add the opposite. And negative 13 plus 27 is 14 over 1. So again, it's moving at 14 inches every 1 second. So why are they different? Because we're looking at different periods of time and where he is, in the water. He's just starting to go up and then further out of the water. And what do they mean in context to the problem? I kind of told us here. It's how fast he's moving every second. Okay? All right, the bell's going to ring, so I'm going to have to pick this back up, but you guys won't notice that because it's just going to be a continued video. Okay, so we're going to finish up this short chapter 8 because it was a pretty quick chapter for us anyway. All right, so you stand on a roof and throw a baseball up into the air. The height of the baseball over time is represented by the graph below, and the height is measured in meters, and the time is measured in seconds, and answer the questions below. So here's our x-axis. That's your time, and seconds. And then you got your y-axis, that's your height, and that's in meters. And they have gone through and already gotten all those important points. These are your x-intercepts, there's your y-intercept, and there's your maximum. So make sure you answer just what the question's asking and not too much. So when it says what's the maximum height, remember x is time and y is height. So when you are going for the maximum height, don't give me both numbers. I just want 15 15.622, and then it's in meters, so I'll put M for meters. Sorry, you couldn't see that. And this point is known as the vertex, or part of the vertex anyway. Okay, so I didn't realize as I was making the video that I got cut off. So I'm going to have to backtrack and repeat some that I already mentioned. So just starting over with this problem, we got this set up. And sorry, you can fast forward if I already said this. I just can't quite tell where it got cut off. So remember, only answer what you need to answer. Don't give more. So what's the maximum height? That is the vertex, okay? Because x is time and y is height. So I'm going to look at the vertex and only answer with the y coordinate, okay? And what point is that known as? That's the vertex. At what time does the ball reach its maximum height? I'd look at the same spot, but this time just give the x value. And I think that was already said. There's a point on the graph with these coordinates. So explain what this point represents using correct units. So it's not a point that they point out here, but it still means that after 3 seconds, sorry, there's my time, the ball is, 1.9 meters in the air. How long does it take for the ball to hit the ground on D? Hitting the ground is when the height is 0, the y value is 0. So we're looking here at this 3.112. So 3.112 seconds, it's known as the x-intercept. What was the starting height of the ball? The starting and where you begin is always the y-intercept. So I'm going to look at the 0, 7, and that's 7 meters. And then I want to think about, this question says, although the function is defined for all real numbers, what values of time make sense in context of the situation? So in other words, what's a reasonable domain? So domain is x. So, I've got all these x values, but I only want to use the ones that make sense. And since time can't be negative, I'd never use this part of the graph. So where it starts is at 0 seconds until when it lands at that 3.112. So I just wrote it like that. Number G, you're going to be finishing this problem. They want to know what's the average rate of change of the ball over its time of flight. So that's just from here, when it started, the y-intercept 0, 7, to when it landed on the ground. And I went ahead and started this. I subtracted my y's first, so the 7 with this 0, and you'll have to subtract the x's the same way. So you do that, and remember, average rate of change wants you to divide this on your calculator so that your denominator is 1. Approximately how long does it take for the ball to return to its original height? And you're supposed to estimate to the nearest tenth of a second. So if the original height is here, I just went across and just kind of thought that that was maybe 2.7, 2.8, 2.6, whichever you think. And then when was the ball 16 meters in the air? Never. The highest point was the vertex at 15.622. So it never got there. And then that's it. One more, which will combine Chapter 9 and Chapter 10.